compression, but they use what we call a Hopkinson split bar or pressure bar to do the test, which is really a ballistic test. So you have a striker here that bumps into this bar at a very high speed, and you have a sample here, and then you record in an oscilloscope, of course, because you cannot use a pen or anything that has very high inertia, and then you translate that into a stress-strain curve. Now, it's very interesting to say, in this stress-strain curve, it has peaks and valleys because of the shock waves, okay? And this is a very old equation, which called Shida's model. Although it's coming below this curve, it's not too bad, at least as far as shape is concerned. But we are talking about 2,200 seconds minus 1 at a temperature we usually at a rough arc. So this is the high point of technology today in these tests. But not for my surprise, but I'm sure I'm going to surprise you. In 1983, some years ago, the Japanese, Professor Yada, was already worried with these kind of things, and he devised this compression machine in which he could achieve 15 milliseconds of minimum pass interval, and the run speed was of 2.2 meters per second, quite high speed, quite a very short interpass times. So with this kind of machine, and with the helping of this machine, he could simulate several processes. And here is a schematic in which you have the strain rate of the process, the interval between deformation, and you can see very short interval, 15 milliseconds, very high strain rate, 300 per second, not 2,000, not 3,000, but 300 per second. And this dotted line here means that that machine can simulate almost every industrial process in the world. Of course, he used plane strain compression, and plane strain compression leads to a very heterogeneous deformation pattern, which is inherent to the test, but it was a great achievement at that time. But we're still struggling with something like that. But he also devised a very speed hot rolling mill. This is the rollers, the rolls, and the furnace, the guide, and the specimen flashes into the direction of the rolling mill. And the rolling mill is very cleverly set because you have a groove for the first pass, a second groove for the third pass, the second pass. Then you can have specimens like that, in which you can have the previous microstructure entering the roll gap. You have the formation here, and over there, softening occurred. All this back then in 1983. Now, how are we now? These equipment are very expensive. We have to dedicate a lot of time to it. So in 1983, we almost didn't have any computers. Nowadays, we do everything at the computers. Then we go to mathematical modeling. In mathematical modeling, CBMM has been striving to get models like this available to their customers, which is, you can see via simulation. Sorry. You can see via simulation, in this case it's a plate mill simulation, the type number 1 behavior where you have static recrystallization. And why I know this is static recrystallization, it's because the deformation given in a pass, this is the deformation, and before the deformation and giving in the following pass, the strain accumulated in the pass goes to 0 again, which means it will crystallize in between passes. When it goes to the finish, this stair-like curve means that I am only accumulated strain, which means pancaking the grains. So I am sure I would be type 1 behavior, type 2 behavior, nothing of mixed microstructure if I follow this kind of schedule. And to give you a counter example, Here I started the finisher passes perhaps at a higher temperature, and instead of having only that stair-like behavior of accumulation of strain, I have a mixed behavior here. You see, strain, partial softening, strain, almost 100% softening, strain, partial softening, and so on. This product probably would have bad toughness properties. And another model, which is also being developed by CBMM, I'm sorry, this it seems to be out of focus, but I'll go to the main features. This is a simulation of a 6-pass hot strip mill, and with this 6-pass hot strip mill I can follow the recrystallized fraction. Then I can tell, look, you have to stop at this point here and wait for a certain time and finish here so that you can have some pancaking. And in this model, as I follow the distribution of grain size, here I started a grain size fully recrystallized, which is type 1 behavior. But as the temperature goes decreasing, I still have recrystallization, as you saw in the second pass. Then unrecrystallized grains appear, which is a mixed type behavior. And after pass, so this pass number 1, pass number 2, pass number 3, pass number 4. In the finisher means stand 1, 2, 3, 4. I can only have some pancaking according to the simulation for that particular schedule in stand number 1, 2, 3, 4, 5, and 6, which means very little pancaking. I come now to my summary. As I said, my intention was to go through all these topics, and my conclusions right from the beginning that I outlined were: we believe that hot strip rolling, it's a very serious business and requires really good understanding of the physical methodology fundamentals. This is the first and foremost point. The second point is that, as I said, there are always pros and cons every physical modeling method. There is no one that replicates or duplicates the real process. So it's best to use a combination of different times, a lot of expertise, of judgment, to get the best results out of these physical modeling methods. And finally, numerical modeling can be used, and they are very useful, at least as a first guess, in the design of a better product and the increase of productivity, and foremost, the reduction of the production cost. With that said, I thank you very much for your attention and patience, and once again, thank you for the invitation and the moment.
I would like to thank Professor Barbosa for this valuable speech. I know myself and you had many information about the specific field of the rolling. That is good for our industry, that is good for academicians. Thank you very much, Professor. Now, I would like to give you a certificate of attendance. Please accept. Let me give you a small information. Because of the time delay, I asked permission Professor Baki Karamış. He accepted my request. His presentation will be at afternoon. So his presentation will be at 1:30. Now we are going to the exhibition hall to see all the sponsor firms that are demonstrated their technologies. And then I would like to thank to Erdemir Group for dear invited guest for us. Thank you very much, everything. Thank you.